Hi everyone and welcome to our channel specialized in designing MATLAB applications. We are presenting in this video a very simple but highly effective one-dimensional nonlinear equation solver. The app is designed to give the users the opportunity to define their functions easily and smoothly, even with zero programming experience. For example, the equation can be entered in symbolic way here, and it can be directly solved at any starting point defined from this box. And the solution is displayed within milliseconds in this box. Furthermore, the app is equipped with a plotting facility, this part, which shows the curve of the entered equation. For this equation, it will show us the curve and the location of the solution point. When we have a solution here, we will see that solution as a point on the curve. Also, if the user tried to investigate more starting points each time he pressed or she pressed on solve, the location of these points will be also shown on the same curve. These solution points can be easily deleted by pressing on the clear button, this button. Also, we have here a reference line at 0 here. We will see it. And this reference line, the curve, and the solution points all can be configured and customized as per the user wish from here. Now, let's start the app to see it in action. Let's maximize it. Now let's solve this equation. Let's see where is the solution. Just press on solve. It will show us a message that the iteration process has converged to a solution. What is the solution? 0. And the location is here. Now let's define another equation. Let's say, for example, sine x times cosine 0.5 times x, for example. And let's see the curve. So this is the curve. Now let's start from 1 as an initial value of x. So if it is 1, then it will start from this point here. So the solution is this point. It is 0. Now let's say that the starting point or initial value of x is 4, which is something here. So it should converge also to this point. Let's see. Yeah. And the solution is not 0 anymore. It is 3.1521. Also, we can start from -2, for example, which is something here, this location. And let's see the solution. So it will give us this location, -3.2315. Now, if someone wants to, for example, customize the curve, we want to, for example, make the line dots. We can do that. We can increase the width to, for example, this value. And we can even change the color. For example, let's say red. So it will be that one. And let's change also the marker. Let's take, for example, star. And let's increase the size to, for example, 25. Okay. And let's also change the inner color or the face color to, for example, which color? Let's take this one, for example. And let's take the edge color to, for example, yellow. Okay. And also we can see the reference line, which is here. Let's say the reference line is, for example, that one. Okay. We can also disappear the reference line. If we don't want it, then we can select none. Or we can select anything. For example, this one. The grid also can be disappeared. The transparency can also be adjusted, and the color. For example, let's take the color, for example, this one. Okay, and we can increase the transparency or decrease it. Okay, and we can also hide it. Let us show it again, and let's select, for example, this one. And let's solve another equation. For example, let's make it more harder. Sine of x times, for example, tan of cosine x. We want to see how effective it is, the program. As I said before, it is highly effective and powerful. So this is the equation, the new equation. Change that one to this, and let's adjust the width to, for example, 2. And let's change the grid color to, for example, this value, and also that transparency to this %. And let's solve the problem at, for example, let's take 1 again. So this is the solution, which is 1.5708. At -1, let's see -1. This is the new solution. We can clear the solutions. We can also continue accumulating the new solutions if we want. Let's say -0.5. Okay, so we're supposed to get solution here. Correct. Now 8, for example. You can see it here. -4. Let's see at -4, starting point. It is here. Now let's say, for example, why we use updatable. We will see that one. For example, it is -10. Okay, -10 is less than -5. So what will happen? Because it is updatable, so the curve will be expanded. So let's see that one. So it is expanded to here. It was up to -5. This part is plotted for us. Now let's disable updatable. So it is not updatable. And let's say now the starting point is at -20. Okay, so it will show us the solution, but it will not plot the curve. It will not be updated. Can you see that one? If we press updatable, we will see the curve. It is very beautiful program, very powerful, and very effective. At the end, you can download the entire project from the links given below in the description box, or by visiting our official website www.matlab-apps.com. Thank you for watching, and don't forget to subscribe to explore more sophisticated applications. Goodbye.